We'll get started here in about 7 minutes. Alright, we're going to get started here in a few minutes. All right, I guess we'll get started here. So I decided to do a little tutorial. I'm sure there's things I'm going to miss, etc. But on what I do when I acquire comet data, actually when I acquire any of my deep sky object data, and how I process it. In case of the comet, though, we process it a little differently due to the fact that it's moving. So I'm going to go through acquiring the data with the scope on the right there, debaying the data, which is basically converting it into color, aligning the comet frames, stacking the frames, and then processing the resulting stacked image using automatic background extraction, color calibration, histogram transformation, curve transformation, and then save the results in the native XISF, which is the PixInsight format, and also JPEGs or PNG format for publishing. So that's what today's agenda is going to be about. So to get started, this is the scope I use in the Northern Cross Observatory. It's a 10-inch f8 RC, basically a GSO RC that I bought through High Point Scientific, but you can get it through other vendors as well. And I use a ZWO ASI 071MC cooled camera, which is this red camera here. And I have a guide camera, a Lodestar 2 that is attached to it. And these two devices are attached to the on-axis guider, which is allows me to guide with the 10-inch while I'm taking images with the 10-inch. This system is pretty automated, and I run it with a camera. So that's the the setup. It's on a G11 Losmandy mount with a Gemini 2 controller, and I have a Optec focuser, which is also computer controlled, and I'm running them all into a Ethernet router that is connected to the laptop over in the corner. So that's my acquisition system and how I acquire the data. Any questions you may have throughout the session, feel free to type into the live chat here on the YouTube channel. So the first thing that I do, of course, is once I've acquired the data, which is I'm going to use an example from last Friday, 10 images that I've got here, and I'm going to use those for the demonstration. So the first thing I do is I will do a complete debaying of all 10 images using the batch debayer functionality, which is right here. And in this script, you can add all the 10 images or all the images you want to use. And so we'll go over and pull them up here from last Friday. So I'm going to pull up these 10 images. It's 10 or 11 here. It would be these. These are all FITS files. That's what the native acquisition camera pulls them up in, FITS files. So I'm going to open those up. And I will do a debayer using the VNG method. There's many algorithms you can pick from. Superpixel bilinear, I like using the VNG. It creates the most useful output. And this is the pattern that my camera has, is the RGGB. And I'm going to select an output directory for that, which for the presentation. And we're going to basically convert all these FITS files into debayered files that'll be in XISF format, which is the default PixInsight format. PixInsight is a very nice tool to do this. So I'm going to execute that, and it'll take just a couple of minutes. And it's doing each frame that I took. As you can see, it'll pop them up there as it's converting them. So whenever I take deep sky images, they're all in FITS format, and I have to debayer them first before I can work on them so that the color channels are all aligned, are used. If you have any questions, feel free to type into the live chat. So I'm debayering these now. That's why I'm only doing 10 of them, so we can get through this in a reasonable fashion. These are all the raw images that were taken last Friday of Comet C 2015 V2, which is also named Johnson. And now the debaying is completed. So the next thing we're going to do is we're going to align the comet frames. And the way we do that is we use the comet alignment tool. So now I'm going to add those files that I just created in the, in the debayer list. Obviously I put them in the wrong place, but that's okay. And what we do in this alignment tool is we pick the first one and we zoom in on the comet, and we pick the comet like so. So now we've got a first point of the point where of the first frame where the comet is located, and then I pick the last one, which is this one here, and I'll pick that. And now what I've done is I've picked the two locations, beginning of the list to the end of the list of where the comet is. And what this part of this tool will do is it will interpolate where it's going to go. And I'm going to put this out into I'm going to put it out in this other folder. It doesn't matter, I've got them reversed, but that's okay. And execute that. So what it's doing is it's going to create output files where each of these are aligned on the comet only and not on the stars. And it's successfully done all 10. So now I've done that. So we can close these now. And now what we're going to do is then the software has determined where that centroid is going to be. And now what we're going to do is do a image integration. So now we're going to add those files that I just integrated, which are over actually in this directory. Just select those. And it's going to now stack all of these 10 images centered on the comet itself. So the stars will be streaked when we're done, but the comet will be stacked. So that's the next thing we're going to do here. So we're going to execute that. I have 64 gigabytes of RAM on my computer, but I don't think I'm using all that much. And I've got a quad core, which has 8 logical cores. If we bring the task manager up while this is running, we'll see what it's doing here. So I'm using about 15 gig of RAM right now, and I'm using a significant amount of the CPU to do this. I have a i7 7700 processor, fairly new. All right, so this is the image that was stacked. As you can see that the stars are trailed, but the comet is not, because we aligned on the comet itself in this software. So now I've completed that portion of the processing. So now this is the image I'm going to work with. So we've aligned the comet frames, we've stacked it, and now we're going to do some processing on that resulting stack. So the next thing I'm going to do is I'm going to do what's called an automatic background extraction. And what that does is it helps with pulling out light pollution issues in the background. It also helps a little bit with the color, but mostly to get rid of artifacts that are not significant to the image. So I'm just going to execute that, and you'll see that the background color will change. Okay, so now this is the image we're going to work with from here on. All right. Now there's a step we can skip if we wanted to, because I've done it both ways. I've processed with the color calibration, and I've done it without the color calibration. For the purpose of this discussion, I'll go ahead and execute the color calibration. Excuse me. What the color calibration allows you to do is use the background and the object of interest as your reference points to do a better white balance effectively. So I'm going to do I'm going to use the area of the comet as this target, and then I'm going to use an area over here that's pretty void of anything. And then I'm going to select those two areas as part of the calculation. And then we'll execute that. See what changes it makes. It made a little bit of change. It actually turned the comet a little bit bluer. It's one of the reasons why I don't always do that on comets. So I'm going to undo this because I don't like what it's done. So I can just hit Control Z and it will undo what I just did. So we're going to leave the color of the comet as more natural, which is green, not blue. So I'm going to leave that as is. But I just wanted to show you that you can do that. And it actually works pretty good when you're dealing with nebulas that are got a lot of color in them. But we'll work with this one alone. And so the next step is to use the histogram transformation. And in this tool, I can bring up a real-time display. As I work on this histogram. So as I do that, I can bring these arrows in and stretch basically the data that's there in this fashion. So I'm stretching the data I've acquired. Notice it's a very short peak across the entire domain, and this is where you get all your significant amount of stretching is in the histogram transformation. That's where you make things pop out a little better. So I'm going to go about right there, and we'll execute that. And that's what it did to this image. So now we've got a little more of the coma of the comet showing up. I don't see much in the way of tail. And then the last thing we do is the curves transformation. And we'll go live with that. And here's where you can do some interesting things to darken up the background, bring a little bit more of the coma out. If you want to tighten up the stars, you can bring the top end down a little bit. I'm doing this all in the RGB region. I mean, you can go crazy with this and really over exaggerate it. See, it might actually be a little bit of tail off to the right there, but anyhow, once you're happy with that, let's bring this down a little bit more. Bring this up a little bit more. And then you just execute that. Or if you want, you can go over to the luminosity trace and you can work on that as well. The more you process, the more noise you introduce, though. That's the only thing, is you can over process this stuff and Get it to look really ridiculous. But get it to where you like it, and then you just execute that. And that's what you have as a result. So that's how we do the comment processing. That only took 15 minutes, which is what I expected. But it kind of gives you an idea how quick you can do that. Any questions at this point? Usually what I do is I save this away as a raw um, XFS file. Let me make sure I go to the right place here. And we're going to call this demo processing. And then that saves it away as an EXIF file. And then you can also save it away as a JPEG if you want. And you can pick how much compression you want on that. So that's it. That's how quick you can do that. Now, if there's any desire to look at how I do some of my other stuff, like DSOs, I can demonstrate that as well. Let me take a quick gander here at where my stuff is here. I can do the equivalent on the NGC object I took. I'll bring that up. The assumption here is I've already stacked it. And oops, I want to pull that up in here. Open. Yep. I'll do a similar thing with this object as well. This is my NGC object. This would be after it's been stacked and debayed as well. And in this case, I'm going to run the automatic background. Okay. So we'll close the source file. We're now working on this one. And now I'm just going to go do a histogram on it. Yeah, I'm doing the galaxy right now. So let's go live with this one. And we're going to stretch it. I got some vignetting and some donuts. Stretch it a little bit there. Darken that up a little bit. Yeah, we moved on to a galaxy too. So you'll be able to replay this video once it's published to YouTube at any time you want. But now we're working on a galaxy. We did the comet already. So this is my NGC 4565 data that I'm working on here. And let's just pick that for now. And then we'll go to the curves. And we're going to do a reset on this. And now we'll work with the curves in the RGB. And I'll pull this down like so to darken that up a little bit. I'm going to pull this one up a little bit. Bring this in a little bit higher. Yeah, it's 4565. Notice all these other galaxies that are in here. I think there's over a dozen in here according to my plate solver software, which is also in this software. I can show you how that works too. So I already processed this once, so I'm not really going to dink around with it much. But I can show you, the kinds of things you can do with these curves, etc. You can really go wild and bring out all the artifacts that are part of your imaging train that makes things look silly. But so we just apply that. in a minute here. I'm going to bring some luminosity corrections in. All right, so apply that. And that's what it looks like with this quick processing I just did. Excuse me. Okay. Any questions? The other thing you can do is you can work on actual individual colors as well if you wanted to. So I could stretch the blue here a little bit. I could make a nice blue galaxy. Let's reset this here. I worked on just the blue. Got quite a bit of green here, so I take some use the blue curve here a little bit. I can bring that into maybe a more natural look. Registack is nowhere near as capable as this. Registack's really for more like planetary, isn't it? So maybe that's a little more pleasing look there. So there's an example of doing a galaxy processing using PixInsight. For those that just joined, yeah, all right. Okay, 22 minutes. That's all it took to do two images. Yeah, Registack is more for planetary. This PixInsight is really good for DSOs and doing processing in those. So the results of the comet that we just did is right here, and the results of the galaxy we just did is right here. So those are two quick ones that we just did in about 20 minutes. It's really nice because the algorithms are already built. Um, they do all kinds of interesting things. Really takes the tedium out of processing when you have tools that already do the things that you want. So those are two objects. The comment we did there at the first session, part of the session, and then I went on to do this galaxy as the second part of the session. So it really didn't take very long at all. Any other questions? Any requests? Well, the only part of the PixInsight that's really intensive is when it uses a lot of memory and resources when you're trying to stack or if you open the files manually and then do work on them. But um, I did a comment sequence a few months ago of 400, I think it was 480 frames, and it took me. I wanted to do a time lapse of them, so I had to do some extra things. The first thing that I had to do was debare them all. The second thing I had to do was actually process them all. So they took, I did all the auto calibration or the auto extract, the color calibration, the histogram, and the curve calibration or transformation on all 480 images. But there's a way to do that automatically using process containers and image containers, where you use one master for the 480 images, and you make the changes on that master, and then you apply it to the um, photo container, which contains all 480 images, and it will process all 480 of them, so you don't do them individually. So for the time lapse that I did for that, I used those tools, which are also in PixInsight, so that I could correct them, stretch them, get a good color calibration to generate the final AVI. And those took almost between an hour and 2 hours per process, and I had to do four processes, and 4 or 5 processes, and it ate up half a terabyte of my disk storage to do that. Oh, welcome. Do I have any lying around of M57? Well, yes, I do. Um, Process pictures here. Uh, let's see here. Where's my M57 here? There it is. No, that's M27. Where's my M57? Interesting, I don't have it sitting here. Oh, here it is. Here's my M57 shot, cropped, highly cropped, um, just to show the center of it. But here it is. Here it is, full frame. This is the full frame I took of M57 back a while ago. Let's see if I got the date on here. I processed it on May 8th, and that's with automatic background extraction and the color calibration process I just went through, the histogram transformation and the curve transformation. I was able to generate this image here. So that's that one. And then this dumbbell nebula was also done the same, similar way. It was actually the same night. I processed it through PixInsight using the tools that I just demonstrated at the beginning of the session. Any other questions? This video will be published automatically once I close the broadcast, and it'll be available probably within 30 minutes, so you can watch it anytime you'd like. Are there any other questions? For those that joined late, I've already done the comment processing, and I did a galaxy processing real quick and dirty using the tools. You'll be able to watch the beginning of this session, and I go through all the tools that I went through. This was the agenda for tonight. Um, Acquiring the data, debaying them, aligning the comment frames, stacking the frames, processing resulting stacked image using these tools, and then I save the results away. So that's what the process was. We did them about 15 or 20 minutes. So it's 8:30. I opened it up for an hour, but I figured we'd probably be done in a half an hour, and certainly we were. Did all the comment work within about 10 minutes, and then another 10 minutes to do the galaxy work. Oh, yeah, Adrian, it's always a learning process. I got 8 people watching now, and we've all finished it, everything we were going to do. Okay. All right. Take care. It's the end of the session.